Hello and welcome. I'm Prateek and this is the first video for Machine Learning End-to-End project. The goal of the project is to cover the whole machine learning journey from collecting the movie data to performing data pre-processing tasks to data analysis and visualization to building a recommendation system using pre-processed data to finally building a Flask movie recommendation application. In this first video, we will cover fetching and extracting the movie data from IMDb website to our local directory and then performing data pre-processing task. So for the movie data, we have two major platforms available to us. One is the IMDb website. So this is the URL datasets.imdbws.com, and other is the movie lens data. So this is also very popular movie data which a lot of people use to build recommendation system. So I will be using this data for the initial task, which is basically data fetching, data cleaning, and analysis task. And to build the model, I'll be using movie lens data. I'll explain the reason why I'm using movie lens data in the end, but for now, let's get started with the coding part. So first thing first, I am going to just import the required packages. So for the initial task, we would require 4 packages: request and gzip. So the data we have on IMDb website is basically in the zipped folders, as you can see, and there are 7 different data sets. So we would need to download this and then extract it to finally get the TSV file. So these data are in TSV file, which are known as tab separated values. They're very similar to CSV files. And then we'll use pandas and numpy to perform the data pre-processing task. So I would just import all these codes, and then how we are going to fetch the data is basically something like this. What I have done in the first step is to create, like I'm fetching 6 files. So this is the URL, a list of URL that I have created, and it is saved in URLs. Next thing what I'm going to do is I have created a for loop which is going to loop over all the URL which are there, request all the data from there, basically download the gz file, and then just extract that file to give us the TSV file. So all those files which are going to be downloaded will be saved here and then extracted as a TSV file. So let me run this code quickly. So these files are pretty big. The files are somewhere between 1 GB to 2 GB in size. So these are big files, but I mean, this is pretty good for explaining the data pre-processing task. That's why I'm using this. For the recommendation model, we are going to use content-based recommendation system, which basically calculates similarity score using some similarity matrix like cosine similarity. And that is computationally very expensive task to do. So if you have a lot of movies, then the final similarity data frame that will be created would be very huge and would require a lot of RAM. So that is not really feasible right now. That's why the final model that I have built is using lesser data, using the movie lens data. So as you can see, we have downloaded all the zipped file, and all those files have been extracted as well. So now I have all the TSV files here. Also, I would like to mention that I have increased the RAM to 35 GB here. You can do that if you're using Colab Pro. If you're not using Colab Pro, I think the maximum that you can use is around 25 GB. So you can go to notebook settings, and in the hardware accelerator, you can choose TPU. If you choose GPU or none, then the maximum RAM you can get is 25 GB. So make sure to use TPU and the running time shape as high RAM. So now we have fetched all the data all the files are here. Now the first thing that I would like to do is import the required files. So that would be my first task. And what I'm doing here is, so title basic contains most of the data that we need, like the title, the year when it was launched, the movie was launched. T constant is a unique identifier for the movies, and runtimes and genres. And also I have already defined, I'm changing the D type of start year here so that I can filter out the year column, or else it is just going to import it as a string column. So that's why I'm doing this. And then just specifying what all columns I need. So that is something I'm doing for title basics as well, for crew, ratings, principals, and names. So let me run this file. And what is happening here is basically, you can see that the directors and writers information is going to come basically from crew TSV file. The ratings is going to come from the ratings file, and the names of all the directors. So these are the encoded numbers which you are going to see here. Every director, every writer, every crew member has an ID. So to map that ID to the name of the user, we are going to use, I think it's names or principals.tsv file. So these are big files. If I have to show you the size, so this one, the names.basics.tsv is around 700 MB. The title.aks.tsv is around 1.62 GB. So these are pretty big files. So this is getting imported. Meanwhile, what I can do is I'm going to just copy and paste the next piece of code which I would require. So after we have imported all the files, so it has been imported. I'm basically going to merge few files. I'm going to merge the basics, title basics file with the crew file, so that I can get the directors and writers information. Then I'm just going to merge it with the ratings as well to get the ratings of all the movies, and then with the principals to get the actors and actresses. So I'll show you what my data frame looks like after I have imported all these things. So this is a new data frame that I'm creating using all these data frames which I already have. So you can see that almost 11.5 GB of the RAM has already been used. So all these data frames that I'm creating, all these data frames are directly being stored right now in the RAM. So that's why this is computationally very expensive process to do. So now if I just show you my data frame, this is what it looks like. So you can see this is the unique identifier for the movie. This is title type, which tells you if it's a TV episode or a short or a movie. And I think there are 6 to 7 different type of title types here. And there are total 4, almost 4.5 million movies are there in this. And I think this is starting from 1893. The first movie that we have starts basically from 1893, and I think we have movies until 2028. So those are the movies which are supposed to be launched in the future, released in the future. So as you can see here that we have few columns which we need, but we have directors as well, we have writers as well, and they have an ID associated with them. So the name, so we need to basically map this with the name, and that is we are supposed to do that for the actors, for genres, for actors, directors, and writers. So we are going to use this piece of code for doing that. So this would basically create a mapping between the director, writer, and actors' IDs. With their names. So since these are really huge files, this takes a lot of time to run, even when you have a system with such a high configuration RAM. And trust me, your collab file is going to run like much better. The system that I use personally right now is a M2 Pro powered MacBook Pro, and still the collab seems to be running much faster than my M2 Pro MacBook Pro. Now this is done. Now I would like to again see what my data frame looks like after I have done all the mapping. And as you can see that I have got the actors okay. So right now what is happening is we are getting multiple rows for one single movie, and that is because of the actors. So for this particular movie, the first movie that you see here with the ID 0005, there are two actors, Charles and John, and that's why two different rows has been created for them. So what I'm going to do is I'm going to bring all of them in one cell, like all the actors for a specific movie, and we are going to drop all these starting and closing brackets for the director and writer. So let me do that. Here using this piece of code, and I would also just rename couple of columns from start year to year and from primary title to just title. So this would basically drop the two columns. The next thing I would want to do is basically just having one row for each movies, and all the actors in one cell separated by a comma. So here I'm doing bunch of tasks. This group by function is going to do exactly what I'm looking for, putting all the actors in one cell separated by a comma. Then I'm just removing like there are a few blank values. I'm removing that from the year column, and I'm creating a new column called movie, which would be basically a combination of the movie name and year, so that there is no confusion if there are multiple movies with the same name. That happens. Like I know there is a movie called Wanted. It's in India as well. It's a Bollywood movie, and there is a Hollywood version of that as well. So that could be a confusion. So that's why I just created a movie column. And so this is what our final data frame looks like. We have the title, we have the title of the movie, the year when it was launched, what is it a short or a movie or a TV episode, and then what is the runtime for that specific movie or whatever it is, then what is the genre, who are the directors for that particular movie, who is the writer, what is the average rating, number of votes from which the average rating has been calculated, who are the actors, and then finally the movie column. So now we have a cleaned pre-processed data which we can use for the further tasks, which would be basically performing data analysis and then building a recommendation model. So I'll be covering all those things in the next video. Till then, happy learning.